Hi everyone, my name is Anshul Sharma and I'm a product manager at Microsoft. A little bit about me, I manage ADX, which is Azure Data Explorer, which is the product that we are going to talk about today. I'm passionate about analytics and all things cloud, and I've been in Microsoft for less than a year. Now, thank you for joining us today. And as I said, this session is about an overview of Azure Data Explorer and basically how you can solve observational analytics problem at scale. So why should you care? So Azure Data Explorer or ADX is a homegrown Microsoft disruptive technology that completely transformed Microsoft's own digital transformation journey. So a journey which began few years back and started with huge amount of telemetry data. Now the same learnings and the product is available to you as a customer as part of Azure Data Suite to solve your business problems with log analytics, telemetry analytics, or observational analytics at scale. So let's see what do we have in our agenda today. Basically, we'll start with what is observational analytics, what are the use cases, what are the common problems that we see with the customers. Then we'll give you a brief introduction of ADX, what are the feature capabilities, what it can do for you. Then we'll talk about some of the common workload patterns that you typically use in your data landscape and where ADX would fit in. We'll also dive a bit into the architecture of ADX, the connectivity options, the reporting options, and so on. We'll cover a lot of customer stories as and when we identify some customer pain points, and we will cover a lot of demos. So at the end of the session, I hope that you walk away with a fair understanding of some of the platform capabilities and can go back and look at some of your own observational analytics problems in your organization and potentially see if ADX or the Azure Data Solution makes good sense of to start using it. So let's get started. So what is telemetry data? So basically telemetry data is everywhere. We find it in IoT sensors, application logs, click streams, user activity. So it drives the advances in the connected devices we find in our homes, smart buildings, smart factories, and in devices that consumers and businesses rely upon. So basically, telemetry is the fastest growing data segment as we race to instrument everything and anything out there. So every activity by humans or machines can be used to optimize our products, user experiences, and how we operate our business in general. So telemetry data is indeed fueling the digital transformation of today and tomorrow. Every day, as you might be aware, like terabytes and petabytes of data is generated, but just in terms of the data complexity and volume that we have in hand, there's an estimation that we'll have more than 175 zettabytes of total amount of data to manage just in the next couple of years. So again, what is the typical nature of a telemetry data? What is it? So basically a telemetry data, which is the digital imprint of every activity, is fueling the digital transformation and it's generating petabytes and exabytes of data every day. So basically this data fits into the classic 3 V's of big data, which is variety, velocity, and volume. So what I mean by that is basically very often this includes a lot of text and semi-structured data in addition to the structured data. So it's a lot of different varieties of data that's coming in. It's not structured most of the time. That's the nature of this data. You have semi-structured data like JSONs or even free text in most of the cases. As this data is streaming in extreme rates and at high velocity, typically there's a requirement of analyzing it with an extreme low latency to get the fastest insights. And also the volume of this data is immense, right? So typically, as we said, this is like typically the big data scenarios of petabytes and exabytes. Now, on top of that, this data is typically timestamped and its schema is constantly changing to able to meet the ongoing changes in the real world. So as and when the data is generated, it would be timestamped. So it's important for you to kind of, when you are analyzing it, go back to the time it was generated, and correlate it with some of the other events that are coming in from probably different systems or different devices out there. And lastly, this has few large fact tables or streams, and typically you would also need to join it with some of the dimension tables, which are some of the reference data that you already have or is getting updated periodically. So this is the nature of this telemetry data, which is again, in a nutshell, extreme velocity, mass volume, and highly unstructured in most of the cases. Now, with that, what makes this observational analytics special? What is the challenge in deriving meaningful insights from this telemetry data? So, as you might have already guessed, because of the nature of the data that we just saw, um, the velocity of the business environment is accelerating, as we all know. So, we have the information flowing in, and we are expected to use it to constantly improve how we operate. So the model and report we created last week might not help us identifying next week's opportunity. And the need for ad hoc insights is constantly growing. So that's the frequency changing business questions that we have to solve every now and then. Now the data also keeps changing. So with new types and versions of devices and apps, changing vendors and business partners, and also evolution of the information needs that drives deeper data collection. So a lot is encoded in text or JSON, which is semi-structured or unstructured data, and ETLs, which is your existing transformation flows, can't keep up with the constant change to structure it unless you keep on modifying it with a lot of human effort, right? So it's really difficult to accommodate your curated data lakes or data pipelines if the schema is constantly changing. Also, now these decisions need to be made in real time based on fresh data that's coming in, right? So it's extremely important for your business to have that near real time visibility so that from the data generation to the insights is typically in few seconds or less than that. So on that point, I would just quickly like to introduce you to one of the customer story, which would signify the near real-time importance. So you might have heard about Daimler Trucks. So basically, Daimler Trucks is an automotive industry manufacturer of commercial vehicles. So they are using Azure Data Explorer to power their digital transformation journey by building solutions around connected trucks and connected factories. So just to give you an idea of their scale, they are ingesting more than 9 trillion rows and 900 terabytes of data in ADX, which all is managed, and they are getting the insights out of all this massive volumes of data in ADX. So the nature of this connected vehicle or connected trucks or connected factories is that you need to bring data from all these vehicle sensors, like in this case, connected trucks, factories. You need to bring in different truck configurations, quality and repair information from buildings to build an end-to-end timeline of the products and enabling your team of engineers. So, and data scientists to get the performance and insights out of this massive sets of data that are coming in. So if you think about it, vehicle uptime is one of the most crucial factor in trucking industry for customers to be successful, right? If the vehicles are not running or are not road, that basically is the loss that you are incurring for your business. So with ADX, the telemetry data which is coming from sensors of the trucks have numerous benefits. So for example, you can have a query that monitors the battery performance over time and can detect worse performing batteries for any trucks, right? And identify, let's say, top 5 trucks with the worst performing batteries, identify the affected drivers, and notify them on the nearest service station, all in near time. So It's extremely important to not just analyze or detect, but also act in real time. You can also easily see with Daimler trucks, they can also easily see the truck utilization over last week or month because of all the data that's stored in ADX. And there are other use cases which becomes extremely efficient to build on top, such as track and trace, fleet management, fuel efficiency, telediagnostic, etc. So you can see how enabling or near real time or real time data insights out of this connected trucks and factories help an organization like Daimler to act in near real time with ADX. So coming back to some of our challenges, uh, one of the other challenges in many cases, what we have seen is the cost of analyzing telemetry data is higher than the value it delivers. Because the nature of this data is like the volume of this data is so huge, and typically there's a lot of noise as well as a lot of events that are coming in which might not be immediately useful, but it's also important for you to not drop them and holistically look at them for analytics needs. It becomes very expensive to kind of store, ingest, and analyze it in a platform. So it's super important to be extremely cost effective in building these systems. So with that point, I'll also want to talk about another customer of ours and how they are solving this cost efficiency at scale. So Tabula, which is one of the world's leading discovery platforms that helps more than 1.4 billion monthly users explore what's interesting and new across the open web, generating approximately 30 billion personalized content recommendations every day. So there's a good chance like you have been given some recommendation in terms of what content to watch by Taboola, and you might not know about it. But just talking about the scale of Taboola, they have over 45 terabytes of data coming over every day. Uh, and Taboola started with an on-premise solution, which they had previously, and they used to sample approximately 10% of the data to be able to continue monitoring SLA, um, effectively losing the ability to troubleshoot and conduct RCA, root cause analysis, for an incident, right? Because you're not looking at holistically all of the data that's available to you, only sampling 10% because it was extremely costly to analyze such data at scale. And after moving to ADX, Tabula makes a sense of billions of lines of logs migrating to ADX. They were able to analyze 100% of data in a cost-effective way without losing any insights. So you can see ADX has drastically improved Tabula's data processing speeds, and also it enabled high throughput data ingestion from the different inputs that Tabula had and providing that near real-time latency. So compared to hours and minutes, which it was previously, Tabula moved to getting insights into seconds, which is pretty awesome if you think about it. Now, moving on, one of the other challenges is also about looking for unpredictable phenomena, right? So the key element, if you ask me about observational analytics, is that you're looking for unpredictability. You're looking for things you didn't look for yesterday. Otherwise, you could have created aggregation as the data comes in or as a standing query, but it would only answer the thing that it was designed to answer, right? Typically in your well-curated data warehouses. So we will talk about how different analytics engines coexist or are purpose-built for different workloads in a bit. But especially I have an interesting story here to share regarding like discovering unpredictable phenomena at scale, right? So there was another customer of ours, and we were working with one of the well-known ride-sharing app in the world, and went into a joint workshop to investigate certain things such as price fluctuations of taxis at airports. So while we were working together with the team of data scientists, with the customer team, we were able to identify with ADX that there is a pattern where taxi drivers arrive at the airports, turn off their driver app, and wait. Now, as soon as there's no demand, there's no supply, the demand goes up, the supply is non-existent, so prices go up. and then everyone turns on their app almost at the same time and get rides at surge prices. So this is kind of, if you think about it, an inventory fraud which is hard to predict in a traditional well curated data warehouse solution. So basically you need the ability to run this ad hoc analytics at scale, to identify these trends, to identify if something is going wrong or something is going well with the business. So this is a very good anecdote that I like to share with the customers, or with the audiences, on how observational analytics at scale can really help you discover some of the insights that you didn't even know existed at the first place. So with that, I'll like to introduce you to ADX. So what is ADX? So ADX is basically a big data analytics cloud platform optimized for interactive ad hoc queries. Now I know it's a bit of a mouthful, so let's try to break it down. So what I mean by big data is basically it's an append only stream of records. So any machine or user generated records of data coming in, you can keep on storing in ADX at massive scale, in real time or in batch as you wish. Now we saw the nature of such data is typically consists of three V's, which is high volume, high velocity, and high variance. So the platform supports different structured data like fully structured, semi-structured, and also free text. So there's um, no schema definition that you need to work on at the start. You can basically have a flexible schema as and when your data starts evolving. Also, it also supports relational query models, so certain things such as filtering, aggregation, join, calculation of columns, it's all inbuilt in the platform. Uh, it's fully managed, so it's a cloud-only platform or a PaaS service, so it's fully managed. You don't have to worry about provisioning or patching it. We would take care for you, so you can only focus on solving your business problem. As a platform, as I said, it's a platform as a service, and you can build your solutions on top of it. In some cases, we have a lot of ISVs or independent software vendors who have built their solutions on top of ADX. Um, and it's optimized or purpose built for this telemetry analytics or observational analytics need. And also with ad hoc querying, right? So the few examples that we saw earlier, it provides you the ability to run your queries on demand with rapid iteration to explore the data, and with inbuilt dashboards that we will see in a while. So just in terms of some of the features that ADX provides. So basically, it's a near real-time analytics platform on observational, which you can run on observational data at petabyte scale. So as you saw with customers like Taboola, Checkpoint, or even Daimler and Microsoft as well, and many other companies, they all understand the business opportunity that lies in telemetry data and the associated challenges that comes with it. So all of them picked ADX to realize this potential. So what makes ADX a perfect fit for observational analytics, right? So at the heart of it is there is a super powerful relational analytics engine that supports filtering, aggregation, joins, deriving calculated columns, and many more powerful operators. And then leveraging a unique combination of column store and what we call as inverted index technologies, ADX offers extreme performance or petabyte scale for interactive analytics, right? So we have customers storing or ingesting more than petabytes of data every day and running this analytics seamlessly at scale. Now, ADX has native support for telemetry data like structured, semi-structured, all the way to free text. The data is available for query within seconds to support near real-time insights, so you don't have to worry for data freshness, which takes a few minutes or hours. No, with streaming ingestion capability that we have, literally within seconds you can get insights out of your data that's coming in. And also, with the nature of observational data, as we saw, we also have a powerful yet human-friendly query language called KQL, which is Kusto Query Language, which is optimized for ad hoc exploration of data. So ADX also supports SQL, but we also provide a powerful KQL Kusto Query Language, which we'll see today for this ad hoc exploration. Now with that, I want to introduce you to first demo. So in this demo, we will be analyzing some of the GitHub events. So as a user, I'm sure you have encountered or worked with GitHub. So this demo is all about analyzing some of the GitHub events. All right. So this is how the home screen of ADX Web Explorer looks like, right? So here you have a lot of options to ingest your data, query your data, create dashboards. But quickly, for this demo, I want to showcase you the query capabilities. So if I go to Query tab, I have few ADX clusters which I have configured already, and I have a database called GitHub. So this database contains approximately 1.2 billion event records since January 2016. And you should not believe me, but actually see it. So if you see, I ran a query to just summarize the total events of that are there in the database in the specific period. And you can see there are approximately 1.25 billion event ranging in this particular time period that exist in this particular database. Now, what is the size of this data? So this is the command wherein I'm just kind of calculating the data size and converting it into terabyte. So you can see it's approximately 3.2 terabytes of data, right? So what you're seeing on screen right now, and let me just expand or zoom in a bit, is KQL, which is the Kusto query language. So basically, KQL is where you would run all these queries on top of the database, and it has a syntax. Basically, you can see it's works with a pipe operator, so you can define a table name followed by a pipe operator followed by some of the commands that you need to show, right? And yeah, like moving on, let's look at some of the um, data. I'll just expand this as well. Let's look at some of the schema of the data that we have in caution. So I'm running a command which says get me the schema, and you can say I have approximately 7 columns, and these are the types. So which is like ID, type, payload. You would see something like dynamic here, right? And this is where gets interesting. So we talked a lot about ADX supporting semi-structured or free text data, right? So how does that support? So that is with the help of this dynamic column. So in dynamic columns, you can just dump your JSON data, and then you can even query on top of that. So what do I mean by that, right? Now let's take a sample of the data. So what I'm telling here is just give me 10 rows from the data just for us to see how does it look like. So if you see here, this is how the data looks like. There is ID, type, and you can see the fields actor, repo, and payload are JSON fields, right? So if I go into payload, basically this is just a dump of, let me expand it for a bit. Basically, this is just a dump of some of the additional information that GitHub sends when for a specific event, like comments, which repo it belongs to, certain IDs, email ID of the committer, and so on. And you can see the type of the events are different events altogether, right? Push, commit, and so on. So this is basically a complex data with some structured as well as semi-structured data. And now we will see how we can run insights on top of this. So what I would do next is run a query wherein what we would try to do is look at three specific events, which are push event, watch event, and issue event, and summarize them by type, right? Just to see how does that look, the payload looks. So if I run this query, you can see all these three events have distinct payload type. So it's not that the payload column would carry a JSON with a similar structure. No, for each type, the payload data and its structure can also varies. Like for push event, this is the payload. For issue events, this is the payload, right? So ADX really allows you to store this semi-structured data without having any constraints on our side, right? And still allowing you to query it dynamically. So now, since we understand the data schema, we can start by having or exploring this data to get some meaningful insights, right? So let's run a query which is specifically looking at one type of event, which is watch event, and look at what are the top 5 popular repos, right? Just by looking at watch event. So what I'm saying here is GitHub, give me where the type is watch event, summarize the number of count based on the repo name, and give me the top 5 most popular repo name based on watch event. So it's going into all this 1.2 plus billion records, running the analytics, and you can see within 4 seconds, it returned the top 5 popular repos out there. And you can see Free Code Camp, TensorFlow, these are Facebook's React at some of the popular repos out there. Um, yeah, now let's give it another shot, right? And let's tune the query a bit. So in this is a bit complex query, but what we are trying to say is we will give different weights for watch event and issue related events, right? So what we are saying here is this is a join where we are saying for watch event, give us some top repos and also join it with the events wherein we are looking at issue comment or issue events, and then based on that, based on weightage of 0.3 for watch events and 0.7 for issue events, rank return top 5 repos by popularity, and not just return that, right? Render a pie chart or bar chart for me for easier understanding of this data. So let's see what happens behind the scene. So this is again a complex query wherein you are running on 1.2 billion plus of records, and it's running across 2 different queries doing a join, and as an output you can see it has written me a nice bar chart in terms of what are the top 5 popular repos out there based on the weightage that we have given. So you can see Kubernetes is very popular, so is VS Code, Spark, and so on. So you're using the powerful capabilities of the engine to create these 2 data sets and query in real time. Now, it's great to see VS Code in the list because we all love VS Code. But what we can do is go a bit deeper, right? And run additional query wherein I want to dive deep into this particular repo, which is the Microsoft repo, and see what's happening there, right? So what I'm saying is where repo is Microsoft, give me all the total events and give me all the 5 popular open source technologies in Microsoft repo, right? So let's see what happens when we do that. So this is again a specific query. You can see it return within few seconds some of the top 5 most popular repo names that are there. Like VS Code is the popular, then TypeScript, VDS stars, and so on. So you can see you can really start diving deep or drilling deep or run those ad hoc analytics very seamlessly based on the semi-structured data that's available. Now, even going a bit deeper, right, in this, now let's focus on VS Code and TypeScript. And ADX has a lot of inbuilt time series forecasting and anomaly detection functions, right? So using one of those functions, which is analyzing the time series, what we are going to do is look at the popularity trend for this top 2 repos over the past 2 years. So what I'm saying here is in the GitHub repo, where repo name is VS Code and TypeScript, uh, create a series based on the time range for this repo name, and then extend it with this function that we have to return the trend for top or return the trend for top 2 years, right, or past 2 years. So let's see what happens when I run this query. So you can see in this how VS Code is trending up, and you can see it's kind of a trending up trajectory, while TypeScript is more or less stable. So this is the trend analysis that the function calculated, which is the series fit line. So based on the series that is generated by the data, this is the upward trend for VS Code, while the TypeScript trend is so far steady. So you can see it's so easy to create some of this visualization and analytics all with bunch of 4 or 5 lines of query code. Now, let's make it more interesting, right? Like, let's try to detect some of the technology hype. So nowadays, what I did is I added some of the few keywords such as GDPR, blockchain, and quantum, and let's look at all like let's see which of this technology trend is making more news, right, in the past 12 months. And this is the query for that, wherein I'm defining, where I'm asking, wherein I'm running a query to get some of the information from repo and looking at mentions and seeing if any of these technologies have been mentioned, and eventually creating a time chart of it, right? So let's run this query. Um, and see which is the most popular technology these days. So you can see Azure is quite popular. There's a lot of interest in Azure and it's trending upwards. So is blockchain. So there are a lot of mentions for blockchain, quantum, Spectre. So this is like a nice visualization wherein you can look at what are the different trends very quickly, right? That are affecting your specific needs. Now, just I also want to show you some of the advanced capabilities at this point of time. So as I said, it's basically ADX is also provides some of the advanced visualization and time series analytics capabilities, and also anomaly detection and forecasting. But what we can do is look at specifically time series analytics, right? So for this particular query, we will look at all the events over a specific time. So you can look at GitHub event, specify a range of date that you want, and summarize all this event for an in a time chart, right, to create a time series. So within this range, what does the time series look like? So you can see for each event type in the database, it created a time series. So you can see this, the push event time series is kind of the most popular time series, followed by create event and so on, right? So you can individually look at how of all the different types that are available and start analyzing what it looks like. So it's extremely easy to run the time series analytics, and you can think of it now, instead of the GitHub events, let's say IoT devices events are coming in, right? So idea remains similar. You can analyze time series for a device, for a series of device, and identify any trend in them. Now, just moving ahead, let's look at an example for anomaly detection, right? So in this example, what we would do is for GitHub event for a specific time range and for a specific type of event, which is push event, and we will say whenever the payload contains Azure, like any push event which is related to Azure, we would create a time series similar to what we did in this example. And we would also ask to calculate anomalies, right? So there is a function that is inbuilt in ADX, which is series decompose anomalies, and you can tell that function to create or detect anomalies and also display it in an anomaly chart. So if I run this particular query, you can see that in the blue this is the time series, and in the red these are some of the anomalies that have been detected, right? So these are some of the spikes, these are some of the days wherein compared to the normal day, you can see the system has detected that there is an anomaly. So it becomes very easy for you to perform your advanced analytics with just a bunch of line of KQL queries, and you can really start getting insights of your terabytes and petabytes of data. The last function for this particular demo is forecasting. So it's very similar. We are giving a time range, and what we are saying is based on for the push events, let's forecast for the next week in terms of how the trend would proceed, right? So again, it will create a time series first, and also with the function that has been provided, forecast next week's time series decomposition. So you can see the blue line is the actual push event trend, while the orange one is the forecasted one. So that is what the forecasting for the next week for this particular event based on the past trend looks like. Yes, so again, just to in summary, as part of this demo, we looked at GitHub data set, which is more than 1.2 terabytes rows and 1.2 billion rows with 4 terabytes of data, and then we ran some advanced analytics and some basic analysis on top of that. The idea was to show you how KQL works and how it is really easy or seamless to run this on top of your data set. So coming back from the demo, now let's talk about some of the common cloud scale analytics pattern and where ADX fits in, and also some of the common customer scenarios. So basically, um, there are three broad common workload patterns when it comes to data analytics. So the first one is your traditional modern data warehousing, wherein you have those curated data models, ETLs, to transform data into those curated data models, which also deals with unstructured data. And the problem statement would be typically like we want to analyze data coming from multiple sources and in varied formats. Now, you would also, once you have that data, also need to have some machine learning on top of that. So we want to leverage the analytics platform for advanced fraud detection. So typically in the first bucket, modern data warehousing, you would use in the Azure world, Synapse Analytics or Synapse Data Warehouse. For machine learning, you would use something like Azure ML. Um, and then the third bucket is real-time analytics. So this is where you can see the problem statement would be something like we're trying to get insights from our devices in real time, right? So this is where ADX fits in. This is where ADX kind of shines. And this would be the observational analytics use cases that we talked about. So in general, these are the three workloads, and we'll talk about how ADX integrates or has synergies with all of them. So again, what are the common scenarios for observational analytics? So for example, building near real-time big data analytics for custom event of logs data, right? So there might be a telco company which is ingesting terabytes of data every day on their subscriber call data, network data, and analyzing it to improve subscriber experience. Similarly, a major oil and gas company ingesting millions of credit transaction logs to analyze the health of payment systems on gas stations. Then a large media company ingesting terabytes of CDN data to analyzing and improve the live streaming experience for their subscribers. Also, a large logistic company ingesting millions of shipment tracking records and analyzing. So all of these are typical ADX use cases where and how our customers are using it. The second bucket would be something like building centralized near real-time observability solutions for all telemetry sources. So you can centralize your log data and build solutions to meet your scale. So this would be like your time series or time observability solutions for telemetry sources. And the last bucket would be something like security log analytics, wherein companies or organization collect logs, use it for observability, like how infra or software is working, trying to find phishing, hacking, attacks, looking at network logs, looking at IP addresses, traffic coming from it. Then customers who are migrating from Splunk to Sentinel and using Data Explorer to complement long-term analytics, and ISVs, which are building security log analytics solutions like Checkpoint, Trend Micro on top of ADX. Also for IoT analytics solutions, customers and ISVs are building time series or IoT solutions with ADX. So they're building cloud-based historians in combination of Data Explorer, Data Lake, and Spark. So tons of use cases in connected devices, manufacturing, energy, oil and gas, and automotive sector, right? So these are some of the common scenarios where ADX shines. You can visit our stories page to learn more about them. I'll share it in a bit. And these are some of the happy customers that are using Azure Data Explorer today, right? The list is in no way complete, but these are just few like Grab, Dodo Pizza, Daimler, Checkpoint, and you can check them all out on our customer stories page. Now, just in terms of sheer scale of ADX or Kusto, by the way, I'll talk about it, but ADX also known as Kusto internally. So that's why you will see me using both terms interchangeably. But just in terms of sheer scale, ADX ingests more than 100 petabyte of data daily, allowing our users to run 1.4 billion queries per day. The total data size managed is more than 8 exabytes, and more than 2.4 million cores of VMs are kind of running ADX. And we have a very happy and enthusiastic community of more than 350,000 KQL developers who are happy with the way ADX helps them solve their observational analytics need. So if you think about it, it's already being massively used, proven at scale, ready for your use cases. Just a bit of trivia in terms of how this technology came in existence. So as I said, this is a homegrown product in Microsoft, and it was built to meet the growing demand of various Microsoft cloud services. So it was launched back in 2015 internally, and as I said, internally it's called Cooster and used widely across different Microsoft products for telemetry analytics. So such as Office, Xbox, Bing, LinkedIn, all are using ADX for log or telemetry analytics needs. It also the underlying warm store for some of the solutions that are built on ADX, such as Azure Monitor, Application Insights, IoT Central, and so on. Um, and lastly, it's also available as PaaS since 2021 for our customers such as you, who can start using it to build their own solutions. Now, we talked about the workloads such as data warehouse, ML, and how ADX fits in, right? So that is where, if you're familiar with Azure Data Story, Azure Synapse is the umbrella which provides the Azure Data Warehouse as well as the Spark Analytics engine. And as part of the Azure Synapse suite, Data Explorer is also available as an option for you for your telemetry analytics need. So basically, to complement our existing SQL and Apache Spark pool, which are available as runtimes in Azure Synapse, Data Explorer is an additional engine which is basically Azure Data Explorer available as part of Synapse ecosystem, also known as Synapse Data Explorer. So if you're using Synapse for SQL or Spark workloads today, then in the same workspace, you can use Data Explorer as an additional engine and seamlessly try to get insights out of your data based on your use cases or based on the customer workload patterns that we talked about under just one unified experience. So you can ingest your data, use any of the engine of your choice based on the use case that you have, and all part of one experience. Now, just diving a bit into the Data Explorer architecture. So as I said, it's a PaaS service, so you don't have to maintain any infrastructure. The cluster includes two types of compute: data management, which is responsible for ingesting your data, and engine, which is responsible for running your queries, right? So as part of this ecosystem, we have managed ingestion pipeline from some of the popular Azure services such as Event Hub, IoT Hub, storage, and so on. And you can bring data out of it along with some of the connectors, which I'll quickly talk about in the next slide. But these are some of the sources through which you can bring the data, put it in ADX, and on the right hand side, you can also see some of the end user dashboard, such as ADX also has an inbuilt dashboard, which we will see in the demo, but also popular integration with Power BI, Jupyter Notebooks, Grafana, and so on, right? So you can see it's an end-to-end ecosystem supporting most of the connectors on the left hand and most of the popular dashboarding tools on the right hand side. Yeah. So just in terms of, as I said, we try to support rich varieties of sources, formats, and pipeline for easy ingestion of data into ADX. So it pulls data from external sources with managed pipeline like IoT Hub, Event Hub that we talked about. We have SDKs in all the popular languages. We have connectors and plugins for Kafka, Spark, Logstash, through which you can bring in your data. And we also have a wizard to bring in your data via UX, right, which I will show it in the demo next. And based on the connectivity of your choice, you can bring the data in. And ADX supports basically two modes of data ingestion: batching and streaming. So streaming is when you need as low latency as possible, typically sub-second latency. You can enable streaming to stream data from different data sources, and start getting insights out of your data in near real time. Now with that, this brings me to a second demo. So in this, all right. So this is an end-to-end demo wherein we'll ingest some data, query some insights out of it, and also create a dashboard for wider distribution. So you can see This is the data pane wherein you have options to bring in data from multiple systems. So you can ingest data from local file, blob, container, ADLS Gen 2, Event Hub, and so on. So for this demo, I'm going to ingest data from a local file for simplicity. And I have a data set which includes the storm events in US divided by state for the past few years. Once I've uploaded this file, which is a CSV file, you can see in the next screen, the system has automatically detected the table structure based on the data format. Now here you have option of changing the data format to JSON, to some of the other options that ADX supports, but in my case, since it's CSV, it's been auto detected. And now I have an option here to modify the table structure if I want to, like add new column, delete certain columns, and so on, and delete the data types and so on, right? But I would keep it similar because this is exactly what I want, and start the ingestion. So once I start the ingestion, the data is sent to ADX and it's been ingested, as you can see, and it's available for query. Now let's move to the query tab. So this is where we would try to run some insights out of our data set. So you can see what we would try to do first is basically uh, see like what is the record structure and how does it look like. So you can see I have I've taken a sample data set, and this is what that looks like. It has basically state, event type, what kind of a event it is. Let me just expand it for simplicity, latitude, longitude, where did it occur, and so on, right? Now, basically, we can also see how many records are available in the system. So you can see there are approximately 60,000 rows. And now we can start running some advanced analytics on top of it, right? Like for example, I can summarize the total number of events, and also the total number of distinct event types, right? Like for example, I might want to say by per state, how many events have occurred over the last few years, and take maybe the top five events by count, right? In this case, so what we can do is we can just store this count of the events in a variable, and then use that variable to take the top five in descending order. So all I'm saying here is give me summarize all the count of storm events, and also give me all the distinct event type by state, and give me only the top five based on their popularity. So you can see Texas had most number of storms, and there are distinct 27 different event types that occurred, followed by Kansas, and so on. Quickly, we'll write another query to kind of specifically look at the specific event. Like for example, I'm interested to look at only flooding that happened in a specific state. So I can say where event type equal to flood, and I want to summarize at this point how many counts happen by state, similar to what we did on top. So I can say give me all the event counts, and just what I want to also do is maybe filter it even further, and only look at some of the events wherein they cross certain threshold, right? So in this case, event count greater than 100, and I just don't want to return the data in a tabular format, but also have a nice visualization created for me, right? So you can see it becomes very easier to read right now, like for flooding based on percentage. These are some of the popular states that happen, and then I can easily convert it into a bar chart or any visualization to see what's happening. So yeah, you can see with KQL, Kusto query language, it's extremely easy to run this analysis on top of your data. All right. So the next step is creating dashboards for wider consumption, right? So now you're running this query. Let's see how we can create dashboards out of this. So if I go to the dashboard panes, this is where I can create dashboards. What I did is I've just created a sample dashboard for you to see how it looks like, right? So you can have different visualization at part of it. You can add different specific charts. You can also add maps and run your geo analytics on top of that. But just for simplicity, to continue our example, what I would do is I would add a visualization into this very quickly, right? So we would just use the query that we had written and create a dashboard here for consumption. So I would just copy the query that we had that we had wrote for understanding what is the flood event type by state distribution, and this is the data it returns. Now I can create a visualization here very quickly. I have multiple options like bar chart, pie chart. For this example, we'll create a pie chart. I can just give it a nice name, flood events, and save it. So you can see it's so easy for me to add a new visualization and create this beautiful dashboards, which are also insightful for your business users and rest of your folks. So yeah, so basically, just in summary, we saw how to ingest data in the data pane. We queried the data out of the data that we had ingested, and we also created a nice visualization. At this point, you can share this link with. All right, back from the demo. Now in the last leg, let's talk a bit about pricing, common use cases, and how you can get started. So with pricing, ATX offers a flexible cost model. So you have the option of choosing a dedicated capacity or reserve instances. So as it's a PaaS service, you basically don't pay per query usage, right? You can select a SKU that works for you. You're not bound by cost per query. There's the biggest advantage of this model is you have a predictable cost. So based on the data ingestion needs or query needs, you would be able to accurately say this is the cost you would pay for the next few months or years. Um, it offers a decoupled storage and compute model, so you can always keep on changing your SKU or increasing the capacity without even affecting the underlying storage. It's extremely easy to switch between SKUs after provisioning, and it also provides ability to start and stop the compute, right, or pause the compute when you're not using it. So essentially, we offer a different and variety of CPU optimized and storage optimized queues and dev test queues based on your requirements. So please do check out the pricing page if you're interested to know more. Now, lastly, in the last leg, as I said, right, it would be important for us to go across some of the common use cases across different verticals that we see. And these are typically the log and time series analytics use cases across industries. So first of all, it might be either in consolidating and correlating logs and events data across on-prem, cloud, and third-party. There might be a classical also use case might also be about replacing legacy large log search solutions or accelerating your AI ops journey, such as pattern recognition, anomaly detection, or also building your IoT analytics. So based on the domain that you fall in, there are different use cases such as in retail, web analytics or clickstream analytics, IoT analytics, in oil and gas, the industrial IoT or historian time series, in security, which is one of the most popular domain that we cover. It's security analytics, threat detection, and also in automotive, we saw like manufacturing, connected vehicles, and fleet management, right? So basically, ADX becomes a central observability platform for your logs, traces, metrics, and events, providing the time series capabilities. Now, how do you get started? Like what you can do? The good part about ADX is you can literally start for free. So if you visit this link or this barcode, we offer you a free ADX cluster, which is a 1-year trial, but Microsoft automatically most likely renews it every year. So basically, you don't even have to key in your credit card, and there's a zero friction onboarding that you have. You would get one cluster per person. Typically, the spec of this is 4 cores, 8 GB 100 memory, 800 GB of data, and it's basically a SKU for you to get started, to get start exploring ADX and see if it fits your analytics needs. So I would highly encourage you to visit this page and earn your free cluster. And lastly, I want to leave you with some of the links which might be helpful if you want to learn more about ADX. So there's a product page which you can visit. Also, some of the reference architectures wherein you can see how ADX integrates in your or can play with your wider data analytics needs. And also, there are some free online courses that we offer in Pluralsight as well as in MS Learn, which you can definitely go and subscribe or start learning more about ADX. And yeah, please do check it out. Now, I want to definitely thank you for staying with me for last 1 hour, and I hope you enjoyed or learned something from the session. Please feel free to share your feedback with me or connect with me directly on the handles given below. And thank you for joining the Data Platform Summit. I hope you enjoy the rest of the sessions. Thank you.